Petty's Corner, we're going to look at the binomial theorem. And what that is below we have this Pascal's triangle. And what happened is in the 13th century, the Chinese discovered a pattern of numbers that we could call this Pascal's triangle. So what that means is we're going to use this triangle to determine our coefficients of the expanded binomial when we have something like the quantity of a plus b raised to the power of n, such as something like this. X plus 2y raised to the 7th power. This is kind of a shortcut we can use. We can see that this pattern is symmetrical. So what you notice is when I go down the first kind of sideways this way, obviously I'm going in sequential orders. I'm counting by ones. If you look at the next kind of diagonal there, you can see 1 plus 2 gives me 3, 3 plus 3 gives me 6, 6 plus 4. So you're adding, the numbers as we go. And if you keep looking at that pattern, you can see that happens as well along the way. 1 plus 3 gives us 4, 4 plus 6. And the same type of pattern occurs if I go down the other side. Okay, so it's pretty interesting. So let's take a look at how we're actually going to use this. And we do have some rules. Okay, the directions are going to say expand each binomial. So what that means is usually if we had something, for instance, something like x plus 2 raised to the 8th power, that would be in the most simplest form. But when we're saying expand it, we're saying, multiply that out. So the number of terms you're going to have is the exponent plus 1. So in this case, I would have 9 terms. The sum of the exponent in each term is also going to be that value. And that value for n is going to be the exponent of the first and the last terms. Now, how do we use Pascal's triangle? So you're going to look, in this case, it would be 8. You're going to look at that row. The value of the exponent is the row you use. And then you're going to use the pattern for the coefficients. We're not going to include this first one kind of at the top of the triangle. That doesn't count as a row. Then we're going to start with the first term, and the exponents are going to be in descending order, and the second order, they're going to be in ascending order. And if the binomial has a minus, for instance, if it's something like x minus y to the 6th power, then we're going to start with a minus, and then we're going to alternate between plus and minus. And then at the end, if you need to, you're going to simplify all terms. All right, so let's take a look. I numbered these rows so that we're ready to go. And let's just kind of work through this. Now, what I did is I wrote them out just to make things a little bit easier for us in teaching this lesson so that you can understand how things are going to go. So for instance, I have a plus b to the 5th power. So I'm going to go to the 5th row. And now I'm using all my exponents are right there. Okay, they're going to be my coefficients. So for instance, I start with a 1. So my exponent there is 1. And I have a to the 5th, right? A to the 5th is there. I would really have times b to the 0, which is 1. So I don't need to write that one. All right, let's look at our next term. So now I go to my row. My 5 is my coefficient. Now my exponent was a to the 5th, and now I'm going to go in descending order, so that's a to the 4th. And now I'm going to add 1b, b to the 1st. That 4 plus the 1 for the b equals 5, which is what I want because I have a to the 5th. And the pattern continues. My next coefficient is going to be 10. My a is going to continue to decrease. My b exponent is going to increase. And again, every time I add them together, I'm going to still get 5. Now, the good thing about this, which I always like, if you kind of lose your way at the end, so I keep going again, 2 plus 3 gives me 5, a plus 4 gives me 5. And at the end, at the very last term, my coefficient would be 1, which is what I have. And I just have b to the 5th, right? It would be considered really a to the 0, b to the 5th. And I know my coefficient is 1. So if you kind of repeated something or used wrong values, that's kind of one way to check that you should be out of coefficients when you get to that end of the row. Okay. All right, let's take a look now. Let's take a look at the next one. Again, this is our 8th row. So we're going to use this row to make sure we are okay along the way. Okay, so one thing we can check, you can see I had the exponent, the coefficient is 1, and then we went to 8, 28. Now again, notice that my sign was a negative. So this first term is positive, and then from there, the first sign I actually write is negative, and then I alternate back and forth, right? I go plus, and then minus, then plus, then minus. And again, I'm using all these coefficients, 28, then 56, then 70, 56, all the way through. All right, so let's take a look kind of at just the first few terms. I don't know if we need to look at all of them, but you're certainly welcome to pause the video and try it on your own. So I have a negative. My coefficient is going to be 8. And again, I'm in descending order. So t goes to the 7th power, while w then goes to the 1st power. 7 plus 1 gives me 8, which is what I want. Okay. Now my next term is now going to be a plus. I use my 28. Again, t goes to the 6th, while w climbs to the 2nd. I add them together, I get 8, and so on from there. Now, one other thing to notice is our first and our last terms we said in our rules is our first and our last term is going to be that power, and is the exponent of the first and last term. So my first power is t to the 8th there, and my last power is w to the 8th. So that we also took care of that rule as well. Okay, now let's take a look at one that's a little trickier. I'm bringing Pascal's triangle down here as well. Now again, we're looking at the 4th power. So I have my 4th power is going to be here. So I'm going to use those values, okay? So this time my first term is 5 to the 5a, and my second term is 4b. So I'm going to have to include that in parentheses when I'm raising it to the power. Again, that's a negative, so I'm going to alternate my signs. So I have 5a to the 4th, and then again, here's my 4 for my Pascal's triangle. 5a, now this 4 goes to the 3rd, and I'm going to add 4b to the 1st. Again, using Pascal's triangle, I'm now at a positive 6. Now again, that 5a drops to the 2nd power, while the 4b raises to the 2nd power, and so on from there. Okay, now on this one, we're not done. Okay, so we have to kind of clean everything up. So 5 to the 4th gives me 625, a to the 4th. Okay, now I can use my calculator for these and kind of do it all at once. 5 to the 3rd, I can multiply that by 4 and negative 4, and I'm going to end up with negative 2,000, and I have a to the 3rd, b to the 1st. Okay, do the same thing with my next term. I'm going to take 5 squared, multiply that by 4 squared, and multiply that by 6, and I end up with plus 2,400, and again, a to the 2nd, b to the 2nd. I keep going. Negative 4 times 5 times 4 to the 3rd gives me negative 1,280, a to the 1st, and then b to the 3rd. Okay, and then my last term is 4 to the 4th, and that gives me a positive 256, and I have b to the 4th. Now again, one more thing to add, we have the power of 4 here, so we should have one more term. 4 plus 1 gives me 5 terms. So I can check to make sure I didn't skip anything. I have 1, 2, 3, 4, 5, and it looks like I'm all set. Okay, let's look at our last one. We can also have questions that just ask us to find a specific term. So again, we're working with the 4th term, so we are looking at that row right there, and it's asking for the 4th term there. So I'm going to do 1, 2, 3, 4. So my coefficient's going to be 4. I wrote this up here. 1, 2, 3, 4. That's that row up there. So I have 4. Now think about it. This is going to be my coefficient. So this a would be to the 4th, to the 3rd, to the 2nd, to the 1st. And then I know I need to add those together. I need to get my second term is going to be to the 3rd power, right? Because I know that this 3 and this 1, when I add them together, I get 4. So 3 to the 3rd times 4 gives me 108. A to the 1st, b to the 3rd. So again, we can just use Pascal's triangle, just that row. We don't have to do all the terms. We can just work on a specific term in that binomial pattern if we need to. Okay, thanks so much for stopping by today. You have a great day.